welcome back to Orlando Math Learning Academy. My name is Huy Nguyen. I'm a math instructor in Valencia College, and this video is a series of video lecture in College Algebra course that is offered by Valencia College or Seminole College or any college in Central Florida area. So the last video was the end of chapter 3. Today we're talking about a new concept, and this concept I may consider it as one of the most important concept in college algebra. Okay, in this concept, in this lecture, you will see the purpose of simplification and the purpose of factoring. Back in the day, when you learn how to factor a trinomial, sometimes you don't know what is that for. So today we talk. You will see the purpose of that. You will see why we need to factor and why we need to simplify polynomial. Okay. So the concept today is about quadratic equation and quadratic function. Okay. So let's write out our title, our topic: quadratic equation and function. Okay. So in the first section, the first part of this lecture, let's talk about how to solve quadratic equation. Quadratic equation. So before we jump to the method of how to solve quadratic equation, we need to know what it means by quadratic equation. What a quadratic equation look like? Okay, quadratic equation basically, again, is this equation, and because this is equation, when you solve the equation, you solve for the x value that satisfies the equation. More importantly, this is quadratic equation. It means the equation that's in a quadratic form. Okay, and because this is in quadratic form, so it contains three term, or sometimes we can call it a trinomial because it contains three term. Okay, and in the quadratic equation, it is a second degree equation. Okay, so first let's talk about its definition. Quadratic equation is second degree equation. You already learn what it means by second degree polynomial, right? So it contains three terms. The first term is in second degree, the second term in first degree, and the last term is constant term could be in 0 degree. So quadratic equation is the second degree equation that has standard form of ax squared plus bx plus c equals 0. Okay, so you see over here, obviously we clearly that we have three terms. The first term is x squared, the second term is bx, and last term we call the constant term is c. Okay, so in this standard form, ABC are constant. Because I mean ABC is a number. Okay, and ABC we call it coefficient. Okay, A is called leading coefficient. Okay, particularly A is called leading coefficient. Okay, so this is the full form, okay, of quadratic equation. Okay, or we can say this is in standard form quadratic. So full form or standard form, we can say it kind of the same thing. All right. And now we talk about the purpose of factoring and the purpose of simplification. Okay. Because we can solve quadratic equation using several methods. One of the method is called factoring method. Okay, and we have to use something called zero product property. Okay, so zero product property. And the property states that if we have the product between A and B equals 0, okay, then we can imply A equals 0 or B equals 0. Okay, and we can solve a quadratic equation using product property by firstly, we factor the quadratic equation into a product form. Okay, and you already learned how to factor quadratic, or you learn how to factor trinomial. It's not hard. Okay, so after we solve that, and we can apply the zero product property, and we can get the x value. Okay, for example, so this is the first method of solving quadratic equation. Okay, I want to solve x squared minus ax equal negative 12. Look at the problem. I see that this quadratic equation is not in the standard form yet, because the standard form, the numbers must be on the left side, but however, what we have here, the number is on the right side, so we need to move the number, need to remove the number to the left side. Okay, so after we remove it, we try to factor this trinomial or quadratic form here into factor form by using Smiley method, or you can use something called AC method, which you already learned in the past. Okay, so I try to use Smiley method, which is the try and error method. Okay, so this x, and we have -6, -2 equals 0. Okay, I'm just go pretty fast about the part of factoring, because that's what you already learned, so I don't want to repeat that anymore. So after you factor that, and we apply the zero property here, so this part over here become A, and that part over here become B, so we have A times B equals 0. Okay, then we can imply A equals 0 or B equals 0. So from here, this is just solving basically in the equation. We have x equals 6 or x equals 2. And what does it mean? It means that when you plug in the x value, 6 and 2 into the original equation, it satisfies the equation. Okay, it means you plug the 6 into here and here, and you combine this, it gives you -10. That's what it means. Okay, so this is a quadratic equation. This is a method. The first method we learned how to solve quadratic equation by factoring, or by zero product property, because we use zero product property. Okay, the second method, let me see, the second method I can use to solve quadratic equation is called square root method. Okay, the square root method. The square root method states that if we can square both sides of quadratic equation to get the x value, but the quadratic equation must be in the form of x squared equal a. In the form of x squared equal a. So if it originally, if it is not in the form of x squared equal a, then we cannot apply the square root method right away. Okay, so we have to manipulate some way, somehow. You convert it so that it is the form of x squared equal a. Then after you have the form, you can square root both sides and you can get the x value. Okay, let's go through the example. You will see clearly. Okay, example 1. X squared minus 24 equals 0. This is quadratic equation because it's a second degree equation. However, this is not full quadratic equation. It's not in the full standard form because the standard form has the middle term. The standard form has a middle term right here. Okay, and for this one, we don't have the middle term. We have the first term and the last term only. Okay, so in this case, by looking at that, I see that I can use square root method because I can manipulate some way somehow so that in the form x squared equal a. Okay, by adding both sides by 24. So after adding both sides by 24, I have x squared equal 24. Afterward, I take square root both sides of the equation. Okay, square root both sides, and square root of x squared equal x, and square root of 24 give you what? It's give you plus and minus of square root of 24. Okay, because when you take square root both sides, basically it gives you plus and minus right over here. Okay, give you plus and minus over here, and I can simplify square root of 24 to 2 square root of 6, and I have the first solution is 2 square root of 6 positive, and the second solution is negative 2 square root of 6. Okay, so that is good because you see that in this example we don't need to do much to convert the original equation into the form of x squared equal a. But some of them is hard. Some of them we need to do more than just adding both sides by 24. For example, example 2. For example, I have something like this. I have like 3 2m minus 5 squared plus 6 equal 60. Now you can see clearly that it's not in the form of x squared equal a at all. But again, I can manipulate some way somehow, and I see that over here I can consider as a. Alright, so if I remove it and I remove 3, then it might give me the form x squared equal a. Okay, so go ahead, do it. So 60 minus 6 is 54. Divide both sides by 3 because this is multiplication. If I divide both sides by 3, what I have 18. Alright, then I see that. Oh, there you go. This is a right here. So I have a squared equal to, oh, I have x squared. This is x, I'm sorry. This is x right here. I have x squared equal to a. A now become 18. So if I apply the formula, I can take square root both sides. If I take square root both sides, I have 2m plus 5 equal plus minus 18. Okay. So now I can solve for the m value easily. So I just go ahead split up apart. So m will be 13 over 2 and m will be negative 23 over 2. Oh, I forgot to take square root. I'm sorry, do take square root over here. So square root here, square root here. So it will be square root of 18. I'm sorry, square root of 18 minus 5. That's 5 over 2. And square root of let me see. Oh, did I do something wrong? This should be minus. Oh, I'm sorry. This minus. So plus. This is minus. So it will be negative square root of 18 plus 5. Negative square root of 18 plus 5 over 2. So we have two solutions. Okay. Okay. So basically that any equation, any quadratic form, I can use either I can use square root method by converting in the form x squared equal a, but for the factor method, which is the one I have to use zero property, sometimes the quadratic equation cannot be factored. Okay, so the square root method we can use for any. However, the zero product property we just can use for some of them, because some quadratic equation we cannot factor. Again, if we cannot factor, we cannot solve for the x value. Okay. So this is the second method of solving quadratic equation. The third method is quadratic formula method, and the quadratic formula said that I can use the formula to get the solution of quadratic equation right away, and the formula is x equal minus b plus and minus square root of b squared minus 4ac over 2a. This is the easiest method to solve quadratic equation. Okay. However, sometimes if the coefficient of the quadratic equation is too big, and you see that you have to square it, and you subtract by 4ac, which is give you a pretty big number, and then you divide it. And sometimes it's not a good method, okay, because you have to deal with a big number. But most of the time, I think that most of the students consider this as the easiest method. Okay. Let's try to go through one example. I think this is pretty easy, so we don't need to go really deeply into that. Okay. Example, I want to solve 3x squared plus 5x plus 1 equals 0. So I just need to define a, b, and c. A over here 3, b is 5, and c is 1. So I just go ahead and plug into the formula. Negative 5 plus minus b squared is 25 minus 4 a3 c is 1 over 2a 2 times 3, so give you negative 5 plus minus 25 minus 12 over 6, so negative 5 plus minus square root of 13 over 6. So I have two solutions easily, right? One of them is negative 5 plus square root of 13 over 6, and the other one is negative 5 minus square root of 13 over 6. The good thing about quadratic formula method that I can use this method to solve any quadratic equation. You know, however, in the test, if I want you to solve using a certain method, you have to use the method that I ask for. Okay, if I ask you to solve quadratic equation using the factor method and you use quadratic formula, then you don't get any credit for it. Okay, so that's just the third method to solve quadratic equation. The last one we call completing the square. Completing the square. And for this method, I have to say that completing the square is basically the bigger version of the square root method, because in the completing the square method, we have to use square root method in the last 3 steps. I think so. I think 3 or 4 steps. So as long as you're good at completing the square method, you're good at the square root method. However, if you're good at square root method, sometimes you're not good at completing the square method, and this is one of the hardest. I think this is the hardest method of 4. Okay, but you have to learn it. This is pretty good method, and I think it helps a lot later. Okay. And as I say, because this is the bigger version of square root method, so during the process we have to convert equation to something square equal something on the right hand side, and we take square root. Okay, then we get the value. And the good thing about completing the square method, we can use completing the square method for any quadratic equation that has solution. Okay, of course, for the case that for the solution that doesn't have solution, then we're not talking about that case. Okay, we're talking about a solution. We're talking about an equation that has solution. Completing the square also work for most of the case, for all cases, in my opinion. Okay, let's pick one of the example. I think I can pick the example here to solve using the completing the square method. So for completing the square method, the first step you have to do, you have to getting rid of the leading coefficient, or I mean converting the leading coefficient to 1. Afterward, we just apply square root method. Okay. There's some minimal step in between, but I mean this is 2 main step you have to do. Okay, because if you don't get rid of the leading coefficient, that's be very hard, and if you don't know how to apply the square root method, then you cannot get the answer. Okay, let's do this problem. 3x squared plus 5x plus 1 equals 0. So I want to convert, the little coefficient here is 3 and I want to convert it into 1. It's easy, I just go ahead and divide both sides by 3. So I have x squared plus 5 over 3x plus 1/3 equals 0. So after I do that, I'll bring the constant to the right hand side. Bring a constant to the right hand side. And you see that the coefficient of the middle term here, 5 over 3. I'll take 5 over 3 and divide that by 2. Then I square that. So just go ahead do it. 5 over 3 divided by 2 give you 5 over 6, right? And I square it. It gives you 25 over 36. So what I'm going to do is I'm going to add in 25 over 36 to the left side. And at the same time, I have to add 25 over 36 to the right side in order to make the equation the same. Okay, because you add something to the left side, you have to add something to the right side. That's the basic concept of algebra. Okay. Then on the left side of the equation, we have 3 terms, and we want to factor that in the square form. And I see that this part here, oh, let's do another step. On the left side here, I can rewrite it like this: 5 over 6 square, right? And let's combine these two fractions. I have multiplied both sides by 12 here. So 25 minus 12 is 13 over 36. Okay. Now, on the left side of the equation, I'm going to factor that. I'm going to factor the left side equation, and I see that if I apply the one of the formula we already learned before to get in the square form. You see here, the left side equation here is in the form of a squared plus 2ab plus b squared. Right, because you see here, this is b squared right here. This is 2ab, 2ab, just that. This is 2ab. This is b. This is a, and 2a is x. B is 5 over 6. You see that it gives you 5 over 3x, right? Okay. So I can rewrite this as x plus 5 over 6 squared. Okay. Equal 13 over 36. Now what you see? What do you see? You see that it's in the form x squared equal a. Now I can use square root method, right? I can go ahead and square root both, take square root both sides of the equation. Okay, then I have x plus 5 over 6 equal square root of 13 over 6, and x plus 5 over 6 equal negative 13 over 6. Alright, then I subtract both sides. I have square root of 13 over 6 minus 5 over 6. I have negative square root of 13 over 6 minus 5 over 6. So I have 13 over minus 5 over 6, and negative 13 minus 5 over 6. You see, it is the same. It is the same, right? It's minus 5 plus square root of 13, and it is the same. So completing the square, the hardest part, in my opinion, is the part right here. But the important part is the part when you have to get rid of the little coefficient. Okay. But the hardest part is the part right here. But if you get used to it, then every time you divide it and you square it, I can rewrite this. I can rewrite this as x plus whatever square. X plus the part over here square. Okay. I know it's kind of hard at the beginning, but when you do a lot of problems, when you get used to it, it'll be easy. Okay, let's see. Let me pick another example to show using a completed square. Let me see. Oh, before I'm doing that, I think I forgot mentioning one of the terminology. Very important in the quadratic formula. The part b square minus 4ac here, I call that discriminant. Okay, discriminant. And if b square minus 4ac greater than 0, I have two solutions. Okay, if it b square minus 4ac equals 0, I have two repeated solution. And if b square minus 4ac less than 0, then we don't have any solution. Okay. Alright, let's go back to the completing the square method. Let's do one more example. Okay, example 2. Let's see. Okay, I'm gonna pick this problem here. Kind of interesting right here. Let me say I need to pick someone that has solution, because otherwise it has the real solution. Well, I think I can just pick anyone though. I mean, because you already learned imaginary numbers, so I think I just go ahead and pick anything. So you have 3x squared minus 5x plus 6 equals 0. Okay, and the leading coefficient over here is 3. Again, I cannot have 3, so I divide both sides by 3. So you have x squared minus 5 over 3 x plus 2 equals 0. Okay. Well, I think this problem kind of similar to the one we just did, so I think I'm going to change the number a little bit. How about I change it to change this a little bit. Let's pick this as 4. Okay, do 4 here. Okay, so afterward I have this. I subtract both sides by 2. I want to leave a space here because I need to remember that we have to take coefficient of the middle term, which is 4 over 3 divided by 2 give you 4 over 6, right? Then we have to square that give you 16 over 36, and I have to add both sides by 16 over 36. And on the left side of the equation now, I can rewrite it in the square form because it's minus, so we have to write minus of. But instead of write 16 over 36, we have to write 4 over 6 square. Okay, because 4 over 6 square is 16 over 36, right? Right here, 4 over 6 square is 16 over 36. Okay, then after this I just combine this, so I have 2 times 36 is 72. 72 minus 16 is 56 over 36, right? And I simplified it, so 56 is I simplify 56 is 28, right? 2 times 28 times 2 is 14. 14 times 2, so 7. Okay, and 36 is 2 2, right? 2 times 2, 3, 2 times 2 times 3 times 3. Okay, so I cancel, so I have 14 over 9. Now I can apply the square root method. I take square root both sides, which is give you x minus 4 over 6 positive of 14 over 3, and x minus 4 over 6 equal negative 14 over 3. Then I have me 14 over 3 plus 4. It's negative 14. Oh, I'm sorry, this is 2, so it's 2 here, 6 here. Plus 4 over 6. 2 square root of 14 over 6. Okay, so I don't want to go through this because it's very simple. You should know how to simplify this, and you should know how to combine this, so I don't want to go through that. Okay, so after you learn how to solve quadratic equation, you solve for 2 values. So basically, what is that? What is those 2 values represent on the graph? Those 2 values represent the x component of the intersection point of the graph of the quadratic on the coordinate system. Okay, so sometimes the solution could be both negative. I mean, the intersection point could be on the left side of the x-axis, or sometimes both of them is positive on the right side of the x-axis, or sometimes the intersection point or the solution, the x component of this intersection point, one on the left and one on the right. It means one negative, one positive. So it will fall into one of 3 cases. The first case gonna be something well, let me see. I don't know, do I need to talk about this right now or before? I need to talk about a quadratic function first. Yeah, because you never know what's the graph of the quadratic function look like. So I'm not gonna grab it, but I just want to let you know that that's what the solution means. Okay, the solution represent the solution is the x component of the intersection point between the graph and the coordinate axis. So sometimes 2 solution here, okay, or sometimes 2 solution here, or it could be 1 here and 1 here. So it will be falling into one of these 3 cases only. And if it doesn't have solution, it means we don't have the intersection point. It means the graph never intersect the x-axis of the coordinate system. Okay. So in order to see that clearly, we need to talk about the graph of a quadratic function. What's the graph of quadratic function look like? When we know what it look like, you will you can imagine, you will realize how the graphs intersect the x-axis has or why sometimes it does not intersect the x-axis. Okay, so in the second part of this lecture, we talk about quadratic function. Okay, again, quadratic function is, of course, it must be the function, and the function here is in the form of quadratic. Okay, and we already learned how to use the notation for function, which is fx. Okay. So fx will equal to ax squared plus bx plus c. This is quadratic function, and this is the graph of quadratic function is a curve, and it's pretty special curve because it's in the form of parabola. It's parabolic curve. The graph is a parabolic curve. Okay, so it's gonna be something like this. Okay, so if we have the full form of quadratic function, it means we have ax squared plus bx plus c. The graph will never go through the origin. Okay, so if the graph touch the origin, like this one, like the picture I just draw over here, then the function does not have b or c. It means over here fx equal only ax squared. Okay, and let's consider more into the quadratic function here. Let's investigate the leading coefficient. If the leading coefficient is positive, okay, then parabola will be upside down. Oh, will be open up. So it's going to be something like this. However, if it's less than 0, so we're going to have something like this, upside down. I just give you the shape, okay? I just give a shape. You just need to know that if a greater than 0 is open up. If a less than 0, then it's open down. All right. So you see that in the picture I have here, when a parabola open up, we have a lowest point, and when the graph is open down, we have the highest point here. Okay, the lowest point here we call that the minimum point, and the highest point we call the maximum point. Okay, and the vertical line that goes through the maximum or minimum point, for example, in this picture is this line, and in this picture is this line. Both of these two lines we call the axis of symmetry. Okay. So the maximum point or minimum point, we can find the components of these 2 points here by using the formula we call the vertex formula. So in the next video, I'm gonna talk about how to graph a quadratic function, and how to get the vertex point by using the vertex formula. And I also talk more about the vertex form of quadratic function. Okay, so I think that's all for the lecture video today. Again, if you have any question or if you feel doubtful of any concept in this lecture, just let me know. In the next video, I will give you more example how to graph, and the example of modeling quadratic function, and example of writing quadratic function using using the vertex form, okay, and using the vertex formula. Okay, so I think that's all for today. Thank you so much, and I'll see you next time. Okay, bye bye.